This is my first time to Newcastle University, so thanks for having me. Although all my architects' friends have moved from Sydney to Newcastle, apparently it's the place to be, isn't it? And I've got lots of friends who actually studied architecture here, and they said, you'll have a great time, so thanks for that. As Irene said, I'm the managing director of a company called Cantilever. I went to the University of Waterloo in Ontario. Anyone know the University of Waterloo? It's an engineering university. It does do architecture as well, but it's an engineering university. I'm going to say I lucked out, had a great education. I think you guys might look back and say you lucked out as well by coming to Newcastle, from what I've heard. Are we all architects here, or so we masters of architects? So what are you doing? Masters of architects? Yeah, of architecture. Okay, cool. People working in architectural practices? Yep. Doing architecture or doing DA applications? Are you actually doing architecture? I always say that we as engineers get the fun bit because we do more architecture than architects do, because we don't have to deal with councils. I'm a big fan of ecosystems and collaboration. I hope that comes out in what I talk about today. I think the world is changing. I think that'll come out today. Ecosystems are everything, and trust is everything. So I work closely with architects, right from the very beginning of projects, and that's where we love to be. We don't like coming in at Act 3, because then we just become subservient to the architecture, but we like coming in Act 1 and contributing to the design, or what I call co-creation, or co-creators. Please interrupt me. I've got this formal presentation, but please, if you have any questions during it, interrupt me and, ask questions. I don't want to preach to you, but if I sit here without you interacting, that's what it feels like. So please stop me and ask questions anytime. I've got lots of stuff here, and I'm not sure whether I'll go through all of it. I think the whole thing is probably about 2 hours, and after about 50 minutes, I get pretty bored of talking. So we'll see how we go with what I've got here. But I'm going to start with presenting something to you, a challenge that we have today in the world, but I'm going to present it to you in a way that you've probably never seen before. And I actually think that we're trying to solve this problem at the moment in all the wrong way, and I'm going to try and show you why we're tackling this the wrong way. So I'm not going to tell you what that problem is yet, but hopefully before I get to the end, you'll see what the problem is. So this is a brownfield site. Could be anywhere in the world. I want you to imagine it to be anywhere in the world. Could be Russia, could be, I actually think it's from Oklahoma. I don't know why. But so we're going to build some buildings on this bit of land. So here we are, brownfield site, anywhere in the world. Could be Sydney, could be Newcastle, could be Russia, could be China, could be anywhere. We're going to build some buildings, right? So the first building we're going to build is, can I get there? Sorry, what do I need to do? Right, okay. And we're going to build what I call architectural typology number 1, which is a single residence house, right? So here we are, anywhere in the world, I'm going to build a single residence house. How are we going to build it? Anyone have any ideas? What's the structure going to be? Anyone have any ideas? More than 90% of the buildings in all of the world's single residence houses are built exactly this way. Come on, tell me.
Slabbing ground with frames.
Timber framed, correct. You go anywhere in the world, including 90% of the housing stock in Australia, is built with timber stick framing, right? Developed about 200 years ago in the US when they started to standardize the sizing of timbers, 2x4s. I grew up with my dad when I was 3 years old building timber frame buildings. We still do it today, bizarrely, and it's been going on for 200 years, right? So I'm saying this is architectural typology number 1, which is a single residence house, has a structural solution, which is common throughout all of the world, right, which is timber framing. And they're together, they're linked. I call them a pair. They're a structural and architectural pairing. I'm going to have three of these, right? So that's architectural typology number 1. with a structural pairing of timber stick framing, right? I get a bundle of timber delivered to the site, and I'm going to stick by stick by stick by stick put them together. Typology number 2, high-rise building. Again, think anywhere in the world, right? It's probably not 90%, but Australia's like this. America's a little bit different. But what is the structural engineering solution for this building? Come on. Reinforced concrete. Absolutely. I don't know what the percentage is. It's probably not as high as 90, as I said. But reinforced concrete. So here we are, architectural typology number 2, high-rise building, structural engineering solution, which is a concrete frame building. Right? No brainer. Number 3, steel frame. Bunnings Warehouse, distribution center, steel frame. So again, architectural typology number 3, steel frame. Architectural structural solution is a steel frame, right? Those are the 3 pairings, right? Can anyone else give me another architectural typology that has a structural pairing where anywhere in the world, 95% of the buildings are going to be built that way? Yep.
Super high-rise steel frame, ultra steel frame.
Yep. So if we go back to the high-rise, there's some parts of the world, including the US, where high-rise buildings are done in steel frame. As a matter of fact, there's one in Sydney that was done in steel frame by Mirvac, but basically they're all concrete. But traditionally, these are concrete buildings. So I had the luxury of working, not a luxury at all, of working on the Burj Khalifa when I was at Haida, highest building in the world. It's a concrete frame, right? It has a different kind of concrete core, but it's basically a concrete frame building. So there it is. So what typology have I not put here? Right? What architectural typology have I not put here? In other words, what architectural typology does not have a structural solution, a standard structural solution that's used everywhere in the world? Anyone know? And this is the challenge we have today. This is the challenge that I introduced at the beginning, right? What are we missing here? Anyone have any idea? The missing middle. The missing middle, right? This is what the world needs to build, and we don't have a structural pairing for it. In other words, no one knows how to do these buildings efficiently, right? And that's why we're missing it. It's because we don't have this pairing. And that's our challenge today, right? But look at the comment about the steel buildings. Look at the comment about timber, right? We could do these high-rise buildings in timber, right? So something's breaking here, and this is totally broken, right? So these pairings are starting to break. This is outside our office. I came to Australia in the 90s, and I did dozens of these. They're 3-story walk-ups. And what's the construction? How do we, yep. Brick and concrete slab. Well, just a second. We've been doing this for 100 years, right? And I did it in the 90s, even to the early 2000s, I was still doing these buildings. So what's happened? Why for over 100 years did we build like this, and suddenly we stopped building like this? What's happened? Could be out of fashion?
Profit. The maximum profit you can get from high rise is much more than 3-story.
Absolutely. So if you're a builder, but let me twist that around. I agree with that. You're better off doing high-rise buildings, right? But think about how this is constructed, right? I'm going to take a brick. I'm going to pour a concrete slab. I'm going to take a brick. I'm going to put it on the ground. Then I'm going to do another one. Then I'm going to do another one. 16 weeks later, I'm still doing bricks. Now I'm going to form the slab. Got formwork. Look at this beautiful building. I've got formwork. In order to pour a concrete slab, I need at least 16 different trades, right? And then I'm going to pour the concrete, right? And then I'm going to go again with the bricks, right? No one would dare build like this today. No one would dare build like this today. As a matter of fact, got a great story last week. This is what I'm going to introduce ecosystems to us. Last week, I got a call from an architect who had been talking to me for about 2 years about doing a semi in Western Sydney. And I said, get me involved, or get the builder and us involved to kind of help you through it. No, we're fine. When the drawings eventually came through to us, they got DA approval, eventually came through to us. they presented this to us, right? Budget $1.8 million. It was $2.8 million, right? It ain't going to get built, right? And I said to Hamish, you know, it would have been a good idea to get us in early because we would have told you not to do this. That was done in the 90s and the 2000s, but we don't do that anymore. Nobody builds like that unless you have oodles of money. And I don't even know if you have oodles of money that you'd be building this, right? You're better off doing, anyway, there's better off doing lots of different things, but that's not how we build today. It's just too expensive. So you probably know this, right? You probably know as an architect, this is probably what you do, right? You do a discovery stage. You choose what you're going to actually, so this is the brief from the client, right? And then you discover what you're going to do as from an architectural point of view. You're going to choose, and then you execute. Execute means do the documentation, right? So there's a discovery stage here where you have to discover what you want to do from an architectural point of view, right? This is common to you, but it is not common to structural engineers. And I'm going to show you why. For these known typologies, 1, 2, and 3, right, the structural engineer doesn't have to do any discovery, right? You, as the architect, can actually choose the structure. And in actual fact, in a high-rise building, you can dictate, you know what it's going to be. It's going to be concrete columns, it's going to be concrete slabs, it's going to be a concrete core, right? So there's no, from a structural engineering point of view, for these typologies, there's no discovery. We just execute. In other words, you just give us where the columns are, and we'll just document it, and we'll do the engineering, right? But for structural engineers, outside of this typology, as structural engineers, we need to do discovery, right? And that's the key to the ecosystem, right? So my question is, if we're given something that doesn't fit a typology, I'm not winning any awards here for graphics. This is me scribbling something together. If we're given something that's unusual and it doesn't fit, it doesn't have a pairing, well, how do we build it? What is the structure? And that's where we need to do the discovery. And as structural engineers, right, we are not trained to do this. As a matter of fact, lots of your structural engineers would say, excuse me, architect, just give me your 4 construction drawings, right? And we'll do the building. We just want to execute. We don't want to do this discovery, right? But at Cantilever, or my career, my work, and us at Cantilever, we don't do jobs where you just need execution. We do jobs where you need discovery, right? And that's where we can add value, and that's where I say we need an ecosystem. But remember, steel frame buildings, timber buildings, I'm actually saying that all of these pairings, the single residence house, the pairing with timber framing, the high-rise building with concrete, the warehouse that's steel framed, I think all of them will disappear. Even though we've been doing it for 100 years, I think all of that pairings will break down in the next 10 years because there's lots of things at work here, right? And those aren't often the best ways to build what is a building. So I'm saying watch out for these breaking downs of these pairings. And in fact, us as structural engineers, and no, not us as a group, right? We need to get together in an ecosystem to do this discovery together. That's key. That is key. We do a lot of timber, and you can't do execution if you do a timber frame building, because you have to do the discovery, because otherwise you just do a concrete frame building. Because you can't take a concrete frame building and just change it into a timber building. Timber has its own unique properties that you need to change. So you should start at the beginning with the idea, okay, do I want to do a timber frame building, or does the architecture that I have suit a timber frame building? This is a great story. This isn't winning any architectural awards, but it's a great story, and that is, it's a house in Seaforth. It's an 8-story building, and you drive in off Seaforth Crescent on the roof, and you go down 8 stories. So we're down at the water here, and you're driving in off the street at the roof. Michael the client, moved into the building probably about 6 months ago now, and I rang Michael and I said, Michael, you know, how are you? Are you happy with our decision to do steel framing? Like, what would you do differently again? And he said, Damian, if I built this building out of concrete, I'd probably be about 2 years from moving in, and I'd probably only be on level 3. right? This building went up in 2 weeks and finished within another month, and then Michael moved in, right? And he said, by the way, Damian, I want to tell you a secret. And I said, whoa, what's that? He goes, you were the 8th engineer that I rang. And I said, the 8th? What are you talking about? He goes, no, I talked to 8 engineers before I talked to you. And I said, well, why'd you do that? And he goes, well, I just wanted to see what people thought. And he said, all other 8 engineers recommended that this building be concrete. You were the only one who, so when I first, if you remember my first meeting, when I rang you, I said, how are we going to build this building? Or do you want to get involved in this project? How would we build this building? And I said, oh, I don't know yet. And he goes, what do you mean you don't know? Why wouldn't we do this out of concrete? And I said, well, we might, that's definitely an option, but there's other options as well. And through the course of about 2 weeks, eventually he gave me a bit of information that triggered this should not be concrete. And that is, he said, I'm going to be an owner-builder. And I said, well, you definitely don't want this as concrete, because as an owner-builder doing concrete, every single bit of formwork that you build is the set-out for the building. You want somebody to do all the hard work, which is the set-out, as prefab. So then we started exploring all the prefab options, and that's where we landed on steel. So it was through that idea of the discovery, right, that we found out that this building didn't want to be concrete. And what I think the other engineers were doing, and I don't know what was in their heads and I don't know what was going on, but I think they just wanted to execute, right? They didn't want to go through a discovery process. They wanted, like, this is an 8-story building, it's going to be concrete. That's the typology pairing that I know, and that's what I'm going to do. And I don't want to have to think about this discovery. I don't know how to do it, right? I just want to execute, so we're just going to do concrete. And I think that's where we need to think about what the narrative is behind the client and the brief behind the client to determine what the structure wants to be. I'm going to introduce the word simple here, right? I get calls from architects all the time saying, Damian, I have this really simple building, right? And that always rings alarm bells to me, right? Because this was introduced to me as a simple building, right? Now, so here I was, I hadn't formulated these typologies at the time, these pairings, at the time where I got this drawing, but now I look back and say, well, the reason this isn't simple is because it doesn't have a pairing, right? There's no obvious solution to this. Can it be timber? Can it be steel? Can it be concrete? Can it be glass, aluminium? Like, what is it, right? And I say the simplest buildings, including the Burj Khalifa, are ones that have a pairing, right? If you come to me and say, I have a kilometer-high building, I said, that's simple, right? That's a simple building because I have a pairing, right? So in my mind, it is a simple building. Look at it. It's beautifully elegant. But do you know how long it took us to get here? The discovery process was at least a year, right, on what it needed to be. It is amazingly complicated. Think about the water. Think about the steel. Think about the detailing. Look at the detailing, right? There's nothing simple about this. But yet when you look at it and go, but it is simple. And I say, it's only the ones that are pairings that we can truly call simple. So this is the title of this presentation, and that is, well, how do we determine what the structure wants to be, right? I say that when you open up a magazine, right, and look at a picture in a magazine, what you are seeing there is the final iteration of a long journey, right? So look at the picture and say, well, how did we get there? Right? And it's that journey that is way more interesting in my mind than that photograph, right? It's the journey that we took to get to that point. And that journey is often about what does the structure want to be. And I always say, and I suppose the way that I work is that if it's not coming to me, if it's not obvious what the building wants to be, then you just don't have enough information. So I say, wait. Just keep gathering information. As a structural engineer, maybe as the architect as well, but as a structural engineer, keep gathering information. Remember, I was looking for that one bit of information from Michael that's like, I'm an owner-builder. Yes, I got it. I know exactly what we want to do now, right? So keep getting that information, keep getting the narrative, right? You've got to meet the clients. As structural engineers, obviously as architects you do, but as structural engineers you need to meet the clients as well and understand what their briefing is, what their motivation is for doing it, what is the end goal. and understanding what that narrative is in order for the building, because it will eventually tell you what it wants to be, and that's the moment you wait for, right? And if it's not telling you, then get more information. So how do we do that? So you've probably seen this. I don't know. So most people say, I'm going to build, think of the 3-story walk-up, right? I'm going to build a building that's based on cost, based on time, based on quality, right? This is an age-old thing. And it is important. I'm not saying this is not important, but what I am saying is this is fundamentally flawed, right? Because if you pick up any newspaper anywhere in the world, you can see particularly infrastructure projects, because they're political things as well, but cost blowouts, time blowouts, and quality blowouts. So this way to do it is not the right way to determine what the structure wants to be, right? Because we know that we are horrible at understanding what these 3 criteria are, right? So it's one thing for me to sit up here and say, we don't know that this doesn't work, right? But it's another thing to say, well, what criteria should we use? I'm not saying this is right, but we've had a crack at it, and it's what we call responsible design. And there's a number of different, and I've done this as a little rhombus thing because each of these criteria kind of have different pulls and pushes depending on what the client's brief is and what the success of the project is, right? So we say materials, so that could be concrete, could be timber, could be glass, could be whatever. So materiality is and I don't argue, or I don't get into the argument of whether concrete is more sustainable than timber is more sustainable than steel, right? I don't know whether there's lots of stuff going around. You probably do it in sustainability courses here, like everything should be timber. Well, I don't necessarily agree with that. I think that you've got to use materials appropriately for its appropriate use, right? So, and one of the appropriate uses is durability, is how we deal with durability. So, we have the ability to make buildings last 1,000 years if we wanted to, right? So what would we use if we wanted something to last 1,000 years? Sorry? Stone? Stone. Yeah, love it, stone. I don't think there's an Australian standard for building stone castles. I have to talk to Australian standards about that. But what's the equivalent of stone that we have? Concrete.
No steel.
Yeah, concrete with no steel. Or concrete where the steel inside the concrete is protected enough to not deteriorate, right? So that concrete column there, I think we could happily say that that would last 1,000 years. It's inside, right? It's not a harsh environment here. Probably built quite well, so the reinforcement's protected, right? The challenge, of course, is that we might not want that column, for example. That column's got to go, don't you think? Surely there's a way to get rid of that column because nobody can sit over that side. So, and that is my third one, which is adapt. Is this touchscreen? That's it. Things being adaptable, right? Was this space originally meant to be used like this? No, probably not. But now it is, right? So we need things to be adaptable. So I think if the architectural team knew that this was going to be used like that, maybe they would have thought twice about that column, maybe even the other one. So we've got to think about how things are adaptable or how things can change. Last one is regenerative design. I'm not an expert in regenerative design. I go to Caroline Pidcock, who's my sustainability expert. But regenerative design, do you do regenerative design here?
We know Caroline Pidcock. She has visited us several times. We are discussing a lot with the students.
Yeah. So we're doing a project in Taree with Joe Vaughan from, which was a Living Building Challenge, but we've kind of lost the funding to get it certified, but anyway, it's still guided by Living Building Challenge. So regenerative means not just sustainable, but the building needs to give back, right, to nature, to the world, to society, right? So it's not just net zero, it's a net gain for society. So that's I will talk about Tauri a bit later, but that's regenerative design. Anything there? I mean, there's other ones. Anything there that other people, anyone have any other ideas about what? So we call this responsible design, right? So it's like doing the right thing, right? So using materials wisely, you know, the dematerialization principles, I think, about, you know, eliminating, substituting, optimizing. I had this wonderful conversation with Elizabeth Farrelly about the Ganyama Aquatic Centre. She was highly critical of the concrete being used inside the building, saying, couldn't we use timber or something more sustainable? And I kind of said, you know, concrete in that environment is probably the best material to use, right? Because look at all the swimming pools that have steel inside. Like, maintaining the steel is very difficult, and the corrosion that occurs in that environment it's a highly corrosive environment. And timber, I don't know about the durability of the timber inside that environment either. So I argued that concrete was probably a good choice for the material in that environment because it's the most durable. There are others. I mean, yeah?
Ethics, like ethically, where do you get the materials from?
Yeah. So where is it sourced? Like, where does it come from? What does it travel? Does it come by boat? Is it local? Yep. I think you can say that about consultants as well, like where are the consultants coming from, right?
What about the matrix for like ethical materials in terms of their sustainability? But like, for example, we use sarking to keep buildings dry and breathable, and they last longer, but they're often manufactured by slaves. Like, so like people not earning living wages.
Yeah.
Like, is that ever a matrix that comes into it?
Well, not specifically, I would say, but I think that's probably part of the regenerative design criteria.
Within regenerative.
Yeah. Yeah, like we do a lot of passive houses, and just maintaining an internal environment that is healthy as well is an interesting thing. But yeah, thinking about like what insulation do you use and where does it come from? Where is it sourced? I know cellulose, we get cellulose from Melbourne, which is all degraded paper. I mean, do we have enough information as well to understand where all these materials are coming from? Yeah, that chain of custody is a really interesting debate. Like even the FSC timber, if you delve deep, if you go to Bunnings and buy a bit of FSC timber and try and trace back to where it came from. We've tried to do that, not very successfully, but you should be able to. Apparently, that's the whole purpose of it, is to be able to find out where it comes from. So it's interesting to know where does that chain of custody fit into it, and how do we use it? Yeah.
With that matrix versus the one you showed before with time, money, and quality.
Yep.
Time, money, and quality. Like I like that one. I feel like it fits very well into the quality one of that older matrix. How would time and money start to fit into that one? Like, does it start to blow out a lot of the decisions in like being adaptable, durable? Like, if I guess you just can't afford these luxuries. Or?
So the way that we look at time and money is, we say the best way to think about it is take your budget and say, okay, what can I build for that budget? Rather than taking what you want to build and then putting a time and cost onto that build. You're much better off doing the opposite and saying, I've got a budget, what can I get for that money? And then you can adjust these matrix to fit what that term in terms of quality. I will talk a little bit about quality a bit later because including in terms of 1684, which is the timber framing code. We'll talk a little bit about that. But yeah, and as I said at the beginning, I don't think quality, time, and money is an important matrix, right? It is important. But the challenge with those three is that they're very hard to determine, right? I've just been reading Dusseldorf's biography. I think it was written by his son, Lend-Lease. And when there's collusion in the construction industry in the 90s, I think it was, about the fact that the reason there was collusion is because no one knew how to price these things, right? No one knew how to price the Opera House, right? You can't price these things, and everyone was getting it wrong. So the reason the collusion happened in his mind was because, well, let's just get together and determine what it is, and determine what a good, reasonable cost is, and then, you know, hey, Jane, you go put that cost in, and you'll win the project, and we'll go 10% higher, right? That's the reason is because Dusseldorf said, well, no one knew how to price these things.
Well, and also the extraordinary buildings that are running out of cost, but are extraordinary and create other revenues.
Yep.
If you put in terms of cost, it's something that, so if it's not producing this revenue afterwards, then you can interrogate whether it was worthy or not.
Yep.
But if it's producing what the Opera House, or I'm thinking in other buildings that were running out of cost because nobody knew how to cost it, or
Yep.
because it was a challenging structure, or whatever the reason, or COVID came, or whatever the reason,
Yep,
right? So then cost is always this tricky.
absolutely.
Yeah.
Absolutely. In the short term, I know when they did in Sydney, when they did the new convention centres, they had a 5-year plan, right? They didn't look beyond 5 years. Look at one of my favorite buildings, Sagrada Familia, right? It's how much revenue does that bring into Barcelona and Spain generally now, right? Yes, and I mean, could you have ever priced that building? And could you have ever foreseen what that meant to society? Me, I even benefited from it. I'm not even Spanish, and I benefited from it, right? It actually changed my life when I went there in the 90s, right? Probably what I do today is direct function of that building, right? Because I sat in there and said, I could live here forever. It was magical, right? It moved me, right? And I think that's what you can't measure that, right? But you don't know what the benefit to society is. It's like CLT, right? I love describing CLT buildings to clients because their immediate response is, well, I don't want to live in a sauna, Damian, right? It's like, but it's biophilic and it's like, it's with nature, blah, blah, blah. It's like, it doesn't fly. You don't know what the benefit of it is until you're in one of those buildings. And then you see, Dave and I had the great pleasure of being in the Redfern House, and it's just, photographs just don't capture what it feels like to be in that space. And that biophilic, which is regenerative design, is a very important part of us as humans, I think, to capture that. So I think biophilic design could be on here, although maybe it's captured elsewhere as well. So anyway, this is our attempt to, rethink that matrix, the success matrix. So what I want to do now is just run through some projects that we've worked on and show you the journey that we took to get to where we are. This was a building with Chen Chow Little, perhaps one of their first buildings I did in the early 2000s with them. Before I was really captured by the architectural world, I'm going to say. This is my first real experience with the architectural world. Tony and Steph gave me their preliminary sketches, and I happily went away and did my preliminary sketches and came back to them and presented it to them. And what you can't see is, but to the left there's a cantilevered balcony here. And I had these whopping big 400 deep PFCs, steel PFCs, cantilevering out. And Tony and Steph looked at it and goes, we can't have that. I want this really light, airy, slender bit of architecture, and you've given me this massive, big beam. And so this is my first. I never imagined that anyone would ever question my design. I've never had anyone question my design before. And Tony and Steph were suddenly rejecting what I had done, and I panicked, as I love to do. I'm a pretty panicky kind of guy, and I was like, well, I don't know. He goes, come on, Damian, we've got to think of something else. And he goes, well, can we put steel columns in the garden? No, we don't want columns. Can we hang something from the? No. Can we make it a truss? No, we don't want a truss. Can we do struts up to? Damian, this is all. And then Tony said, did you say a truss? And that's what we ended up doing. So it couldn't have lasted more than 30 seconds of me panicking to kind of find a solution. And look, and this is what I call emergent architecture, right? So this is stuff that Tony and Steph never had the idea that we were going to do a truss, right? And it's, once you get these ecosystems going, once you get these places where people trust each other, it is magical what emerges, right? It is absolutely not what you could ever have predicted. Never did they imagine that there would be a truss, but that became the architecture. Another interesting story about this, I don't know whether you can see this, but there's a connection here. And this was on a crazy tight budget. And Tony came to me one day and said, what's the simplest way to make these connections? And I said, well, I've done a few industrial buildings, and what we do there for the temporary bracing is we just take the tube and squish it, and then drill holes in it, and put it in. Tony goes, that's it, done, we'll do that. So a couple of months later, Tony was in the steel fabricators, fabricating these trusses, these struts, and I get a call. And Tony's panicking, I can feel him panicking. He goes, Damian, we have a problem. I go, what's that? He goes, when we squash one end, and we go to squash the other end, there's no way that we can get them to align, right? So we're going to have these things that don't align. And we need them to align, right? Because otherwise you'll get this crazy connection here. And I said, oh my goodness, I don't know. So in my panicky way again, I was like, well, I don't know, can they hold it in a jig? No, can they grip it somehow so they can squash it, right? Like, what is the machinery? And he kind of described the machinery to me, and I said, oh goodness, I have no idea what we can do here. And I said, I got it. Squash both ends, we'll cut the tube in half, spin it so they align, and weld it back together again. Right, so it was just, I love panicking, right? You get the best out of me when you get me into this panic mode, right? And it just gets me thinking, but there's a lovely Teresa Amabile, I'm a big fan of. She talks about creativity, and time constraints are a way to get creative, to produce a creative solution or innovative solution. So I love having time constraints. I love being under pressure. So I thought it was a cute little story about these squashed ends. 3x2 house. Anyone know this house with Penobscot? Anyone know Andrew and Anita? This is actually used quite a bit for the facade. For facade engineers, it's kind of a case study that's being used. The brief to me when Andrew and Anita, this conversation was more than 30 seconds. The brief to me from Andrew and Anita was that they wanted these two bits of glass to touch. And I said, well, you need structure in there, so they're never going to be able to touch. Yep, we get that. But we want them to be as close as we can, as close together as we can. Originally, I had steel column through the middle, steel column, all of that being a portal frame. And then through a workshop, which was probably more like an hour, we eventually came up with the idea that we'll do a steel as a portal frame, but we'll hang this central portion with a steel plate, and then we'll offset the transoms. And that will get us these two bits of glass as close together as we can. So that was kind of the workshop, or the journey that we took to get to this point. Because the original design with the column in the middle had, 500. The bits of glass were about 500 mils apart. So, and it's about allowing yourself, I suppose, to explore these different options and understand what the brief is and understand, what is possible, right? And I don't mind the idea that people come to me with things that aren't possible. I don't mind that. It's that is Living Building Challenge. Living Building Challenge is, it's almost unachievable, right? But what it does is it drives you to do something that's good, right? So, and as Caroline Pickhook always says to me, don't let good be the enemy of great. So, do what we can. Anyone know this building, Shell Harbour Anglican College? Do you know that I believe that we have the ability to produce buildings that hit a budget, hit time, and are of the quality that we want, right? We have the ability to do it. We know how to do it. It's well documented how to do it. But strangely enough, we actively choose not to. We actively choose not to. Do you know, if something goes wrong on site, if you get a variation on site that was unexpected, right? The common thing to do is to blame your structural engineer, but the common thing to do is to blame someone, right? I need to blame someone. And I say, that's not the right way. There's usually no one individual person to blame. There usually is no one. What you should blame is the process. That is truly what I believe. You should blame the process. Because this building is a classic example of how you can make the process work for you. And this was originally the little blurry vision that was given to us by Chris Rogers at Tarawa. And what Chris said to me was, this is what we need these 3 rooms, and we just want the most efficient building that we can build, right? Whatever it takes to build the most efficient building, that is what we want. So that's where we started. We started there, and that's why I'm saying Chris brought us in to discover, in the discovery stage, what I call stage 0, the discovery stage on how to build the most efficient building that we built. This one came in $200,000 under budget. The first time the Sydney Anglican Schools has ever had a project that came in under budget, right? So much so that, see this little amphitheater here? Which is actually what the school wanted more than anything. They wanted this, but it was a separate project. Because of the savings, we were able to bring it in to the building itself. So this is used by the Sydney Anglican Schools as an exemplar for how to do things properly, and included bringing the structural engineer in early to negotiate how to do this. And there's 10 things, you can read it on our website, there's 10 things that we did to make it an amazingly efficient building. Which includes using cantilevers, of course, right? Every building has to have a cantilever. But also using the same steel beam, 14 of them over the whole building, to take advantage of the steel building. Notice that the purlins go over top of the steel beams, again in efficiency. Notice that there's no ceiling, right? I'm going to write a paper one day on all the buildings that we've done with no ceilings. Why would I do no ceilings? Why would that be a criteria, a key criteria for making this an efficient building?
So you can see the structure?
Of course, so you can see the structure. No, well, and so you don't have to put plasterboard on there or villa board or whatever. But what else? Why would putting no ceiling in there change the structure? Change the structure?
Lighter.
Sorry?
It's lighter.
Lighter? Sometimes lighter is bad because it's actually uplift which governs this. So in fact, weight is good. Any ideas? It's very structural.
You don't need like extra elements to fix the ceiling too?
Don't need extra elements? Sure. That's not where I'm going, but yeah, absolutely. So when we engineer buildings, there's 2 fundamental criteria that we use. Anyone know what those might be? It's not rocket science, I don't think. But then the first one is not rocket science. What's the primary goal of a structural engineer? To make it not fall down, right? So strength. We call that strength. It's got to be strong enough. That's our primary goal. As a matter of fact, everything else is subservient to that, right? It's got to be strong enough. But what's the second criteria that we as structural engineers, not required to do by law, but do? What's the other thing that we need to do?
Efficiency.
Not efficiency.
Like loading.
That it doesn't fly away?
That it doesn't move. It's got what we call serviceability criteria, right? So it's got to be fit for purpose. In other words, if I walked across this room and it started going like this, it's like your structural engineers let you down here, right? We did the Maritime Museum and we actually let it go be like a boat because they wanted to experience it, so we let the deflection criteria. So most buildings, right, are governed not by strength, but by serviceability, right? And with a set plasterboard ceiling, if it moves, what happens? It cracks. Without a ceiling, nothing's going to crack. So if we change the governing criteria from serviceability to only strength. And that's the key to get rid of ceilings. See, there's no finishes in here. We don't have to worry about serviceability. We have to worry about cracking of concrete, of course. But here, suddenly, the only reason this beam can do what it does is because it has no ceiling.
Especially with big lights or big spans. Because
Correct. Bigger spans. Correct. Yeah. So we remove the serviceability criteria. So you'll see lots of our buildings. Yep.
How would you deal with insulation internally
Well, there are ceilings internally. So what we did was, we are so clever here. What we did was, this is the biggest cantilever in the entire building, and it only could be that big because it doesn't have a ceiling. But when you go inside, it is governed by deflection serviceability criteria, deflection criteria, and it does have a ceiling, right? But the spans are smaller. So we chose how big the rooms could be on what that beam could do with a ceiling. And that's the way the whole building was engineered. I've never done a building more efficient than this. Everything about it was that. was driven by that, driven by the efficiency.
How many of these decisions were you making versus the architect making?
So I call that co-creation, right? So you're in a meeting, right? And there's no hierarchy, and that's the key, right? That's where the ecosystem is so beautiful. There's no that's what integrated design is, right? There's no hierarchy. There's a facilitator normally, but everyone's making the decisions together. And in a lot of cases, we actually don't know who made the decision. It's the team who made the decision. Pixar, if you know Pixar, I read a lot about Pixar. It's an extraordinarily successful company. And their whole basis, anyone know anything about Pixar? Anyone know how they do the movies? How do they make these amazing movies? What is their process? Anyone know what the process is? They sit in a room, right, with an amazingly, extraordinarily diverse group of people, including neurosurgeons, including builders, including kids, including obviously the managing director, and they sit in there and said, there is no rules here, and you can never say no. And that's the ecosystem that lives here, right? Nothing's a bad idea. Nothing. Anything goes. It's a safe zone. That's psychologically safe zone. If you can set up that environment, you will build extraordinary architecture, right? That is the key. I'm saying we know how to do it, but we choose not to, right? Why do you bring most of your consultants in Act? Why would you, not you? Why would you bring most of your consultants in Act 3 where you've already made most of the decisions, right? Only say, just be subservient to this design and go. That's not the right way to do it, and we all know that. So this is the way that it needs to change. And with these, going back to the original thing about these breaking of these pairings, right? We have to do this more and more. It's the only way to do architecture, I believe. The only way. Unless you just want to do crap, and then of course you can do whatever you want, right? But if we want to do good architecture, this is the way to do it. We know how to do it. It's well documented. I'm preaching now, aren't I? This is the Redfern House. Amazing. This has a magic moment. I was involved in this project for 10 years before it was built. We got knocked back by City of Sydney Council at least 6 times. And at the end, they would only accept in alterations and additions. So on attempt number 6, we were standing. They've got their artists. They've got a gallery. This is a 2-story gallery. They got a personal gallery space. This is Helen's, the client's artwork, extraordinary. And we were standing when this was just a roof, and we were standing in that space looking up at what would be a floor, imagining what the floor would be. And we're saying, could be concrete, could be timber, could be Bondek, could be, and I turned to the group and I said, what about CLT? And they said, what's CLT? And then 6 months later, we have our CLT building. Had to be lightweight because we're using existing footings. That was key to it. But this is the one where you come up the staircase and turn into this space, and it blows you away. It's got these beautiful lines, and it actually tapers down to the window at the front.
It's on YouTube.
On YouTube. Thanks, David. On YouTube. Check it out on YouTube. Thanks. That's why you're here, David. Thank you. Another project. This is Balmain House with Andrew Burgess. This was the rendering that we got from Andrew at the very beginning. And Andrew goes, I want to explore different things. And I said, well, it doesn't look like to me like you want to explore. It looks like you've got a CLT building. He goes, yeah, I just wanted to see what it looked like as CLT, but let's explore different options. And I said, okay. So we came up with these 3 options. Timber stick framing, structural steel, and CLT. There's lots of other options, but these are the main ones we looked at. Okay, hands up. Who thinks this building is going to be built with timber stick framing? Hands up. Nobody? Don't be shy. I've already told you 95% of the building is good. Okay, let's keep going. Steel. CLT. It's not fun unless you make a decision. So whether you put your hand up or not doesn't matter. Make a decision, right? Because I'm going to go through the advantages and disadvantages to all of these and see if you change your mind, right? As I said, 95% of buildings in Australia are built, in the world probably, are built timber stick framing, right? You go out to tender on this, and you can get every building in Australia, every builder, sorry, in Australia would tender on this, right? And probably the one that you would choose if you're in this competitive mode, probably the one you would choose is the builder who's made a mistake during the pricing and underpriced it, only to get hit by variations the entire process because they've got to make their money back, right? Or they needed the job at the time, but then realized, just a second, I can't build it for that. So this is good for a highly competitive market. Steel, structural steel. So what are the advantages of structural steel? Right. Remember, this could be prefab or stick framing, right? Could be prefab, but let's just stick to traditional timber stick framing. Bundle of timber on site, 2x4s, and you put it all together. What are the advantages to steel work?
Speed, strength, and spans.
Spans. Yep. Yep. Think about the responsible design criteria. What was the other responsible design criteria that we had? One of them, if you remember.
Durability.
Durability. Yep. Regenerative. Absolutely. I was more thinking adaptability, right? Look at the internal walls here. Can't change that. Look at this. We do dozens of these. We do dozens of these a year, right? And you think, why? And we have builders who say, just give me that. My steel fabricator does the set out. It's done in a day. You can put that up in a day, right? And then I come in and timber frame it, and I'll get the client in 6 months, as opposed to this. Beautiful story I have about this is that I walked onto site one day, and the drawings that I had produced were timber stick framing. And I said to David, the builder, I said, David, we can do this as timber stick framing, which is what my documents show, or we can do this as CLT. CLT, I reckon we can do this CLT building in 2 days. This isn't this project, by the way, a different project. We can do the CLT in 2 days. Timber stick framing, what do you think it'll be? And he goes, well, we've already priced it, and we think the timber stick framing will take 6 weeks, right? So I said, okay, 6 weeks, 2 days, yeah, not that much of a difference, right? So I went to site just shy of 6 months later, and they were still hammering bits of timber together. And I said to David, I try to do my Kevin McLeod here because Kevin McLeod has this amazing ability to get people to open up to you. So in my best Kevin McLeod, I said, David, remember when we talked a while ago about the fact that you thought this timber stick framing would take 6 weeks, and we're now at 6 months? How do you feel about that? And he goes, oh, I feel pretty good because we actually thought that it would blow out, and we've actually put that into our price. And I said to David, in the best way that I could, I said, David, that just defines everything that's wrong with this industry, right? Is the fact that it didn't even rain during that time, but yet it took you 10 times what you thought it would originally take, right, to do this build. Why? Not 10 times, but why, right? And he goes, oh, things just happen, and, we just liked hammering bits of timber together, and we're pretty happy here. It's nice, we're down by the water. We don't really want to go anywhere else, so we're quite happy here. So it's like, what is going on here? How can you get that into the price? Like, that doesn't make any sense to us. But you know what? We're all paying for that, right? We all pay for their inefficiency, for builders' inefficiency. That is what I'm saying. It has to change. And that is why these parents are all going to break down. That is why this is not sustainable as a method for building single residence houses, right? And is CLT the answer? No. Is steel frame the answer? No. What is the answer? I've already given to you. Come on, what is the answer?
The best material for the job.
The best material for the job, right? But deeper than that or higher than that. Go higher. It's about the ecosystem, right? Every builder has a different take on this. We work with builders who only do CLT. We work with builders, as I said the other day, somebody said, just give me a steel frame. We work with builders who just want this. There's no silver bullet here. The silver bullet is the ecosystem. We need a builder to get involved so that they can help us guide us to what the structure wants to be, right? Because I don't know. I'm just a structural engineer. And as an architect, you don't know either, because you're not going to build it, right? But the ecosystem can tell us. And including the client. I shouldn't exclude the client there as well. So, anyone know how we're going to build this? Well, in fact, In fact, we got rejected by council, so it's not going to be this at all. But we're doing a different building, which is timber stick framing, right? And whether that's right or wrong, I'm not here to say, right? But the ecosystem said that the builder, including the builder, said, I just want to do a timber stick frame. Let's just do that. And they're not even doing prefab. They're just doing timber stick framing, right? So remember as well that when you're on site for 2 days, as opposed to 6 months, black swan events happen, right? It's going to rain for 6 weeks, definitely, right? Just before you put the roof on, it's going to rain. If you take the roof off, it's going to rain, right? So whereas 2 days, the risks are so small, right? So that's why CLT is advantage, and it's hard to price all of that into these buildings. Another house, and I've got a prop here. So this is the Annandale house with Welsh and Major. Anyone know this house? Anyone paying attention to the architectural world in 2017 because it won an award? So these are the original drawings that I got from David.
David was here last week.
David Welsh.
Yeah.
Did he talk about this house?
No, I don't think so.
Okay. He might have, because you might recognize it in a minute. So I love boxes, by the way. This is a box for holding stuff, but it's also a box. So this is the original building that they gave to us. And you'll probably look at that and say, yeah, that's fine. Right? No worries, everything's cool. But what you might notice is that there's not many return walls in this. So when you think of the most efficient building that you could possibly build, it's this, right? It's a box without any windows and doors, right? Probably not going to win any architectural awards, but that's the most efficient thing. Any movement or deviation away from this is a compromise, right? It's going to cost you money, it's going to cost you time and effort, right? So that's what you want to build, right? Now, putting windows and doors, probably not too big a deal, right? Of course, windows are more expensive than just a solid wall, right? But putting windows and doors in structurally, if we just think about the structure, putting windows and doors probably isn't too big a deal. Changing the external envelope, shaping a bit, kind of we're stepping away. But there are things that you can do to this box which are devastating, right? Anyone know what I could do to this box that's devastating?
Remove the whole side.
Sorry?
Remove the whole side.
That is the most devastating thing that you can do to a box, right? Because it's handy for storage, but it ain't handy to hold a building up, right? But look, yeah, there's a return wall here, but look at this. There's nothing magical about buildings, right? This box undergoes the same principles, right, as this building. It has no return walls, so that's what I'm left with, right? So it's completely unstable. So structurally, we need to get this box to be stable. Any ideas what the options are? What do you mean by trusses?
Yeah, cross-bracing.
You're giving away all my tricks. So, you mean something like this? So, look at this. I mean, I'm not winning any awards here at all, but this is my model making skills at their best. So, whoa, just a second. So, here we go. We're going from something that has no lateral stability, right, to something that is incredibly strong with cross bracing. So, but just a second, how am I going to get through that building? Right? So, do you think David thought that was a good idea? Any other ways? Any other ideas? I've got a bunch of others. We already heard one.
A staircase?
A staircase to do the bracing?
Yeah.
Love it. The crazy thing is, and I was looking at a picture this morning of a staircase in a building that we're doing with Breakspear, and I was like, that staircase is probably holding the building up. Like, we've got other things happening, but we don't often use staircases. Are usually infill. We rarely use them to provide structure, right? Any other options?
Going outside the box.
With what?
Or some sort of like some sort of wall structure to support it going sideways.
You could do inclined. You're hand gesturing inclined columns, but they don't have to be inclined. So another option is the steel portal frame. Again, not winning any awards here, but that see how effective that is? That's a steel portal frame around the outside, right? So, and there's obviously one other option, which is probably so obvious that you wouldn't know it, and that is, well, don't cut the ends out, right? So put something inside, right? Put something inside, right? So I went away with these drawings, and I came back to David, and me being compliant structural engineer, right? What do you think I proposed? So here we are. We've got 3 options. There's a few more. But what do you think I proposed? Do you think I proposed the cross? Do you think I proposed the cross bracing? Right? David, just put some cross bracing in here. Don't laugh, because we have lots of examples. Toby Breakshire has 2 beautiful projects where there's cross bracing in front of a sliding door, right? This is what emerges. This is what I'm talking about emerging. Like, don't be afraid. You go to Japan. There's cross bracing everywhere. What's different about Japan than Sydney or earthquake? Yeah, Newcastle has its own earthquake, which has caused. We were talking about on the drive up, which has caused issues. I think Sydney is going to have an earthquake soon in my lifetime. I'm going to live to 150, but anyway, in my lifetime, I reckon it's going to. You laugh, but I reckon Sydney will have an earthquake. Absolutely, and it'll change everything. Brick will be out, I think. I don't know why brick's still in, but brick will be out. So I presented portal frames. Didn't want to disrupt the architecture. I'm a compliant structural engineer. Didn't want to. So that's what I presented. But David didn't like that, right? He goes, geez. So here's the original one, open, right? So we needed to find a solution. The solution that we proposed was steel framed, and David wanted to expose brickwork, and the steel frames were disrupting that. And David goes, are there any other options? And I said, well, we don't have any return walls, so we could put return walls in, right? So I presented this, and I did it reluctantly because I thought, geez, no one's going to accept these return walls in this space, right? Clearly they want this tunnel, right? Well, but guess what David did? Totally embraced it, right? Anyway, ended up winning the biggest architectural award in New South Wales in 2017.
I'm so sorry, could that stair, as your suggestion, could that stair have worked as a cross brace?
It does provide stability. Yeah, absolutely, it does provide stability. But strangely, we don't rely on it. Yep, we don't rely on it.
What would you need to make it strong enough? So do you need to kind of diagonalize through the other side?
Yeah, it actually doesn't come through to this wall. And we don't know, like the stairs are often done as a last thing. Like originally it was a steel stair, actually originally it was timber, and then it was steel. This is actually outdoor space, by the way. The roof, there's an operable roof. This is actually outdoor. So it was originally timber, then it changed to steel, then it changed. Only at the last minute did it change to concrete. So we never relied on it but what a great suggestion. Why don't we use that as our lateral stability, right? So it's basically a version of this, but instead of diagonal rods, looking around thinking, can we see anything here? But this is concrete building, which is slightly different. You could have one strut, which is effectively that. But as I said, bizarrely, we never considered stairs to be part of the solution. Waterfront Tavern. Anyone been down to the Waterfront Tavern? This is the new pub, which is the town centre, of course. Done with H&E. The kind of architectural narrative for this project was a boat shed, innocent timber boat shed, timber framed, no steel work. So that's what we're kind of driven by. The narrative. So, and this was a rendering that was done later, but it gives you a good idea about what the structure is. And so this is the final building. It has a concrete podium on concrete columns, and above that is a lightweight frame, and it's got these extraordinary operable doors. And thinking about the extraordinary operable doors, effectively, we've got this, right? It's completely open structurally at these ends. So we've got a process to go through to determine what, because this can't be a timber boat shed. Well, I shouldn't say that. Could be a timber boat shed. And so I'll just start with this. So the reason we were brought into this project, this was a project with Frasers. The reason we were brought into this project is because there's a boardwalk that runs underneath the building here. And if you go down there, you can actually run or walk right the way around the lagoon. It's pretty amazing. And we had to keep the structure less than 500 mils or less in this space, otherwise we wouldn't get the headroom in the space. And the original engineers that were involved in this project couldn't find a solution that these beams were, well, they couldn't find a solution where the beams were less than 600 mils. So we were just asked to come in as a peer review and say, can we get these beams down to 500 mils so that we can walk underneath them? And so when you look at that, anything magical? Yep.
Reduce the weight of the building above.
Reduce the weight of the building above? Yep. Yep, so reduce the load. Yep. Anything else? Yep, columns. So these are the concrete piers that support this slab. So this is the concrete pier layout that support the suspended slab. Anything?
Using the roof to sort of hold everything together.
Yeah, bizarrely, we actually looked at that. Yep, we actually looked at using the roof to hold the thing together, right? So it's these spans here, which are the critical ones, which are the ones where these beams needed to be 600 millimeters deep, right? I don't expect you to get the answer, I just wanted you to think.
You beef up the other ones where you don't need to walk under it,
Yep,
to then reduce the ones where you can walk under it.
absolutely, and in fact, that is exactly what we did. Yep, as well as other stuff. Anything else? Anyone remember the name of my company? Because Cantilever screams efficiency, right? So what do you think I suggested that we do? Introduce a... See how these columns are on grid line 1, right? There's no reason for that, right? These are below ground, below, it's all free. We actually shuffled all of these columns in to introduce a cantilever. Right? So what I say is what we've got to think about here is forget the geometry, forget the restraints, forget everything. What is the simplest structural solution? What's the most economical structural solution? Right? And concrete slabs, right? If I was to do a building, if I was to do a high-rise building from scratch, what would I do? I have a brown site and I can do whatever I want. How would I do it? And the answer is quite simple, and we all know how to do it. And that is that we have a cantilever around the perimeter of the building. The first internal span is small, the middle spans are bigger, small span cantilever, right? That's the most efficient one. So the way that I thought about this was that we want to move the solution to that solution. So remember what I said? First internal span small, next internal span big, right? So if we look at this one, we've got a cantilever, that's awesome. First internal span big, second internal span tiny, right? That is the enemy, right? Because we want the next internal span to be big, but it's not, it's tiny, right? So in fact, fundamentally what we did was we removed 1, 2, 3, 4, I might have even removed 5. We actually removed 5 piles. Each of them are about $40,000 each. Right? And we actually made the spans bigger in order to make the beams smaller, right? Don't use that anywhere else in the world, but we made the spans bigger in order to make the beams smaller. How bizarre is that, right? But that's the enemy, is these double columns, right? So we remove the double columns. So again, cantilever, first internal span small, big internal span, and then we were limited by the boardwalk here and the cantilever, right? And that allowed us to get the beams to 500 mils, right? By removing 5 columns and making the spans bigger. I mean, how bizarre. But and it's hard to see. Anyway, that's what we did. And yeah, go for it.
Do you mind technically telling us why that works? Like the first span smaller, the second one bigger. Why functionally is that the way?
Yep. So that's a very engineering. It requires a very engineering answer, but it's all to do with the way a beam wants to work, right? So the best way to describe that is you want continuity, right? Continuity is, and that's why concrete is such a great solution, is because you want continuous spans, right? So, and the way statics work is that if you imagine there's with the two columns, maybe the best way to describe it is, with these two columns, there's no deflection in that span. So this one deflects, has a large deflection, and then there's basically no deflection in that span, and then this one has the large deflection. So if you think about, I don't want to introduce bending moments, but if you think about the deflection of the slabs, think about how this thing is deflecting. It's deflecting, then it's deflecting, and then it's not deflecting, and then it's deflecting again, right? In actual fact, by removing this column, we get this one deflecting more, and it actually makes that one go up. And that's why this is the enemy, because we're making it rigid where it wants to be flexible, so that as I stand here, this one comes up. And it's that idea of continuity which is the key.
Kind of like a seesaw. The heavier weight on one side and a lighter weight on the other side, so it pulls it up.
Generally, I do, not this presentation, but a different presentation for stage 1 to stage 5, right? All the way through high school, actually, stage 6, right? And all I do with them is I get them to tap into their intuition, right? There's no formulas. You won't see any formulas from me ever, right? It's just things are actually intuitive. I actually think that this idea it's actually intuitive, right? You just tap into your intuition and you can solve the problem, right? It's when you get locked into things that you lose your intuition. Do you know that if I told kindergarten kids that if I brought a herd of elephants into up here, they could tell me exactly what's going to happen. It's not magic. You know, structural engineering, yeah, we crunch numbers sometimes. I don't know a lot of crunching numbers nowadays, but we just use intuition. And I didn't crunch numbers to determine that this was better. I just looked at it and said, what does my intuition say? Right? I didn't need to be a genius or a structural engineering genius to know. In fact, when I look back, I said, what were they thinking? Like they were restricted by, the previous engineers was restricted by something. I don't know what it was. But they weren't thinking intuitively about what this building wanted to be. And when you say it to them, I actually think if I went back to them and said what I did, they would say, oh yeah, of course, obvious. But they're locked in by grid lines? I don't know. Like there's something about that they couldn't see beyond. And maybe there's something else going on, I don't know. Maybe they didn't want to do this project and found a way not to it, I don't know.
I have the intuition that is the grid. So they couldn't see how to make the span of 3 of them in one beam.
Correct.
They never think that perhaps they didn't need to follow the grid.
Correct. And we didn't follow the grid.
Yeah.
Yeah, I mean, as you can see, we didn't follow the grid. And it's the breaking of the grid which allowed us the freedom to think about what does this building really want to be, right? You'd be amazed, like when I give this, I am baffled by what a kindergarten kid, and I go to Newington and teach, they are worse at intuition than the kindergarten kids that I talk to, right? You lose your ability, maybe we all do, but we lose our ability we make things way more complicated than they need to be for no reason, right? I believe that all of you can be structural engineers. All of you will have to be structural engineers. All of you are structural engineers, right? Just continue to tap into the intuition that you have. It's not magic. I don't think it is. It's just an ability to see beyond, like to see what it is, to have that mind to solve problems in a different way, right? And I always say, people talk about solutions outside the box. I'm not a big fan of that. I actually think solutions are inside the box, right? And that's why I say in an ecosystem, the solution is between us, right? It's not out there. The solution is between us. And that's what Pixar is amazing at. They're amazing at, all we have to look at is what's between us, and that's where the innovation is. That's where the story is. Maybe that's a philosophical thing. But so this followed a traditional design process where we were given the architectural shape. We do structural massing. So we render this in Rhino. We render it in timber intentionally because we have a timber first policy. Despite the fact that we think, but we want to go there first because often you don't go to timber first. So we render everything in timber just to make us trigger that. We wanted this to be a timber frame building. It wanted to be. So that's how we modeled it. But there were some major challenges. One is the operable doors, has massive loads, the operable doors. And getting timber to take those loads was extraordinary. So we knew that for the operable doors, we needed to support them by steel. There's another area here, which is external. It's the plant room. Again, timber externally, kind of pretty tough. So we thought that needed to be steel. And the third one, and the big one, I could talk about this forever. I have talked about it a little bit, is lateral stability. This is an excerpt from AS1684. Anyone know AS1684? I have a love-hate relationship with AS1684. It's a cookbook for single residence houses, right, up to 3 stories, right? It's an amazing code, packed full of delightful stuff. Anyone, you could pick it up and go build a 3-story building, right? It's just a cookbook, just tells you how to do it, right? So most builders would know how to do it. 20% of this code is dedicated to what they call racking loads. Don't know why, shear forces, bracing. We call it lateral stability. And this is what we're trying to stop. There's 2 different types. There's core diaphragm, and there's distributed frame. There's the Burj Khalifa. It's a core, right, concrete core. There's the Empire State Building. Anyone know how the Empire State Building? Steel frame. Steel frame with no bracing, all portal frames. Oh my God. So apparently they did it before they had computers and everything. So apparently there's an amazing amount of lateral resistance in this building. So you could build quite a few more stories onto this building. It would still provide lateral restraint. Whereas now we've kind of refined it to an art. So putting more floors onto an existing building is not so much about the weight, but about the lateral stability. Because it works harder down the bottom, as you can imagine. Right? So if I push at the top, if I push like this, it's working harder down the bottom because it's got to accumulate all those wind loads. As I was writing this, I noticed 2 different tables in my office. Look at how they're distributed. Look at how the frames are different. There's core diaphragm. There's distributed frame. How bizarre. I thought that was funny. So slowly we moved away from the timber, even though we had a timber, the architectural narrative is timber. Structural narrative, struggling to do timber. So we ended up with a full steel frame, and that's what we built. So there it is. There it is down the bottom. And again, I just wanted to look at the operable arms and see the operable doors and see the arm, see how that's so close together. We wanted them to be, the closer they are together, the bigger the strut load, right? So you want it to be spaced apart. But what we did was the struts, in its full open position, the struts are horizontal and the door is actually sloped. But we worked with Stephen Jones at Renelita to determine all those loads. And the last project I'll do, this is the one in Taree, first stats count that we're doing with Joe Vaughan and Caroline Pidcock, and an amazing builder from Foster, Walter. We had the big opening for stage 1 a couple of weeks ago, and we're going down there again on the 18th of September. The stage 2 is now open. Living Building Challenge, it's not now, but it's guided by the principals. Here's the site. And this was an integrated design. So we had builder, structural engineer, client, architect, everyone at the beginning of the project. So in fact, we started with, well, what are we going to build here, right? So again, going back to the idea that we have a budget, right? What can we build? Rather than, here's the building, how much does it cost? And that was the driving factor behind this. So here's the basic layout. Stage 1 went up to there, and then we've just finished stage 2, which is there. Has anyone been here? Have you?
Yeah.
Wow.
We built the yarning circle there.
Oh, right. Oh, right.
With Caroline and
Yeah, right. Yeah, awesome. So you know the punchline to this story, but don't say anything. So here we are, water. There's a water narrative, which was amazing, done by CJ Arms. Here's the site. And here's the rendering that we had at the, during the design stage. Curved glulam beams, which actually, due to cost, we got rid of the curved and it's just straight glulam beams now. Here's the concrete slab. Anyone know what this is? Water. So why would they do that?
From going off so quick.
Yep. It is the way to cure, is the best way to cure concrete, is to pond it. So very rare to see. As a matter of fact, this is the first Australian building I'm going to say that I've ever seen that Walter ponded it. In hot climates, like did a few projects in Jamaica, it's all ponded because of the heat. But you want to retain them. You don't want the water to evaporate too quickly. It'll deteriorate the concrete. Walter engaged a local glass artist to sprinkle glass into the floor and makes a little river pattern through the center of the building. Here are the glulam beams, everything prefabricated. Some more of the timber beams and the prefabricated walls. Here are the glulam beams. So this was done by Curvewood. So there's a guy named Ron, must be 100 years old there. I rang him and I said, Ron, I got your shop drawings for the glulam. They're the most amazing things I've ever seen. And he goes, what? I've been doing this for 45 years and no one's ever rung me to tell me that they're amazing. So I've asked him to donate them to the center and they're going to frame them and put them up. So these are hand drawn. So the red are the timbers that are working hard. So he went and selected the ones that are the red and the purple ones are working whatever. Here they are being installed. And that's it in the roof. Okay, so this is the last story. Walter rang me and said, Damian, Walter, I'm going to send you a photo. I said, okay. A few minutes later, I get this photo. And I said, so what am I looking at? Is there an owl here, a koala? Like, what's going on? What am I missing? What's going on? He goes, no. Don't you know what I'm thinking? Walter, it's a tree. Like, yeah, it's on the site, and I'm about to cut it down. Okay, well, that's a shame. He goes, no, it's not a shame. What? And there it is. So there's 6 of them that hold up, that were cut down from the site and hold up the roof. Never done it before. You know, if you want, this is emergent architecture, right? There's no one, and this was done on site. No one could ever have predicted that this is about to happen, right? And you know, this is what happens when you're in an ecosystem that where everyone trusts each other, right? If this was an adversarial contract, I would have just said no, right? But that's not what this is. This is an amazingly beautiful, if anyone knows about the Taree, it's amazing, I'll do anything for this project, right? And it was a bit of hard work to get it, but we did it. And there they are. And that's the magic, that is the magic of the ecosystem. And that is why, you know, we strive for it on all of our projects. Get the builder involved. Let's all get involved. Let's co-create this building, right? Don't make me subservient to the design, right? Allow me to contribute. You know, for the first 10 years of my career, I built this silo, and I said, no one comes into my silo, no one, right? You don't mess with my stuff, and I won't mess with your stuff, right? It was Caroline Pickett who actually taught me that I need to demolish that silo, right? So for the last 5-10 years, I've been demolishing that silo, and I let people in, right? On the understanding that they'll let me in too. Right? The bigger your silo, the worse you're going to be at this. I think we've got to work together to create that. And as these pairings break apart, it's becoming more and more important. As sustainability becomes a thing, it's more and more important. As costs become such a huge thing, as the missing middle becomes a thing, we need to think about how the ecosystems are working and how to generate those. One of the key parts of this was the fact that the orientation of the tree was a critical part to how this building worked. And we needed the base to rotate so that we could line it up with the glulam beams because, you know, obviously these are organic things. So we developed this connection, base plate connection that has that. So there's Sam carving away at that to put the glulam in. The end. What do you think? Do you know that I've been a structural engineer for a while now, right? And I've gone through waves of hating it and loving it, hating it and loving it. And it's now that I love it. I love everything about it. Yep, it's such, if you can get it right, if you can get those partnerships right, if you can get the team right, it is an amazing place to be, amazing. So don't let anyone tell you it's a shit place to be, because it doesn't have to be, right? Especially when you live in the contract world. We don't live in contract worlds. We don't live in adversarial worlds. If you go to adversarial tenders, you're not going to get a good outcome. Everyone knows that. And some people are okay with that, right? Some people know how to deal with that, right? But I don't think it's the right way to do it.
It's interesting that I was, so sorry.
That's okay.
So the industry advisory panel meeting we just recently had, that with industry people, builders and architects coming, that was the outcome of the meeting, that decision.
Yeah.
Adversarial contracts, like that was what you were saying.
Yeah, absolutely. So there's thinking about contracts, there's an NEC 3 contract, which is in the UK, which is an integrated design contract. The US has an integrated design contract, so one that's not adversarial, where in the integrated design contract, the number one thing is we will work together for a common goal, right? The reality is that we can all win here, right? I don't know what win means, but we can all win, right? And in an adversarial contract, there are winners and losers, clear winners and losers, right? But if we work together and we know how to do it, right, then everyone can win. There's no reason why, including the client, there's no reason why anyone has to lose.
You said Caroline Pidcock was instrumental in helping you break down your silo. How did she frame that for you?
Yep, great story.
It would be a really structurally sound silo, I imagine. So
Yeah. So she rang me one day and said, Damian, this was a long time ago. Don't even want to think about how long ago. And she said, Damian, I want you to come along to a meeting. And I said, okay, sure, I'll come along. And she goes, I'm meeting the client for the first time, and I want you to come, and I'm inviting Darren, the builder, as well to come. And I said, wait. And this is when, I'm used to coming in Act 3. And I was like, Caroline, well, what do you want me to do? And she goes, I just want you to listen, be there. You don't have to contribute at all if you don't want to, but just sit there and listen. And this is what she told me. She said, if there is ever a moment when I suggest something ridiculous, your job is to call me out. And during that process, I was crazy nervous, as I love to be, right? I was like, oh God, I'm just going to sit there and do nothing. I don't even know what I'm doing here. First time I've ever been in this meeting. And Caroline had never met the clients before. This was her first meeting. And she sat down, and sure enough, in the hour and a bit conversation, I was able to contribute, right? And I came out and said, Caroline, I didn't think I'd be able to, but I did. And so she taught me how to contribute in that, what we call now stage 0, right? How to contribute in those early stages, as to say, do you really, hey client, do you really want to deviate from the box, right? And how do we want to deviate from this box? And I think that, thinking about things simply, like what's the most efficient structure, and when we deviate from that, making sure it's consciously done. Like some people, you say, the deviation here is crazy, right? So there's what do you want to achieve here, right? From an architectural point of view, what do you want to achieve? And focusing on that, right? Focusing on the outcomes. Because when you understand the outcomes, then you can contribute in a way that doesn't disrupt the outcome, but is a more efficient way to do the build, right? So that was my introduction. So I blame Caroline for all of this. And it was 20 years ago, right? And it was through that, and then it's like, okay, I can do this, right? I can contribute. I know how to do it now. And so that's what we train at Cantilever. Everyone knows how to get into those meetings and be a positive contributor, not an adversary. And I think that's what is often seen, especially from structural engineers. It's like, how can you work with architects? But as long as you're not a victim to the architecture, right? And that's what co-creating is about, right? Co-creating is like, I want to be able to contribute to the architecture. Just let me into the silo, and we can both contribute here in this. And so that's the idea. The idea is never to become a victim. And I say to the structural engineers who don't like architects, you're in the execute phase, and you don't know how to do that discovery, right? Because if you knew how to do that discovery, you wouldn't feel victim to the architecture, right? I don't think you need to. We don't need to be victims to it, right? So in actual fact, talking to Mel at Bale, it's like, Damian, you should be telling this to structural engineers, not to architects, because they're the ones that need to come in, right? Or be allowed to come in and not see it as a hindrance or boundaries.
Well, both, right?
Yeah.
I think it's a good reminder for us.
Yep.
Probably also the engineers, because I see problematic that there is this kind of conflict in the profession.
Yeah, absolutely.
Having collaborating with amazing engineers, and yeah, it should be like that. So I'm very glad that you discovered the other side.
Yeah.
And the other kind.
But we've got caught up in this. We've got caught up in this contract adversarial world, I think, and we don't know how to quite get out of it. And our whole industry is set up for that, to deal with that, right? But it doesn't need to be that. Like we're dealing with something that doesn't ever actually need to happen. And I think, yeah, I'm curious about why you think the architectural world is becoming disconnected, but maybe it's becoming disconnected because we don't have the ecosystem going.
Well, my impression is that, or the way I put it is because when I studied architecture, I did 3 years of very intensive structural engineering kind of component. I remember every Friday of my life being in the school 2 to 10, believe me or not, doing calculation and things. I have not been using through my life because I went to the large scale, urban, and so on, but I have colleagues that knows how to do the calculation. So I don't think we need to do that to the extent I did it, because in fact it was a pain.
Yeah.
But I think it's important to having the principles and the knowledge, and being children, having the vision of the children, being able to understand. So if you just want the design and you don't understand the complexity, the structural complexity that is behind, you are missing a significant part, because the challenge of the upper house is structural.
Yep.
It's not only a formal condition, right?
Yep.
And I think it's very important that architects understand that. That's why we're inviting you, and that's why we're pushing them in a certain direction. But it's also very important that we learn how to collaborate, because there are certain things we don't want to do it, or we don't know how to do it anymore, which is this, we don't have this.
And I don't think, like when I hear architects doing bending moment diagrams, I cringe, right? Because that's not
the purpose.
That's not the purpose. The purpose is to go back to kindergarten and tap back into your intuition, right? That's where it is. Don't throw those bending moment diagrams and shear diagrams or whatever in the bin. Just think about, well, what does this building want to be, right? What does this structure want to be? Like, it's not magic. It isn't magic. And I think people make it more complex than it needs to be, right? Just try to simple it down, simplify it so that you can understand what it is, and then think about intuitively what it is. And you get caught up, you do, engineers do too, they get caught up in the complexity of like, this is a really complex thing. Well, if it's complex, and I say, this is how we train our engineers, is like, if you're saying it's complex, it probably is. So think of a way to simplify it. And think of a way that you can contribute. Remember, understand what the architectural vision is, and then contribute in a simplifying way, right? And you need everyone in that group to be open to it. As Toby Breakspear once said to me, he goes, let's think about what design is, right? What is design? Design is the process to get to an outcome, right? So in other words, it starts blurry, and we focus, so that it becomes something that we build, right? And we want everyone to have buy-in, right? Including structural engineer, client, every builder, right? To come in that blurry phase, and we'll focus it together, right? And one of the tricky ways that I suss out whether it's going to be a collaborative environment or not, right, is I say, I'm going to put a steel column right in the middle of your kitchen, right? And it's interesting to see how people react to that, right? Because some people say, get out, I never want to see you again, right? And it's like, I'm not doing it, and other people want to understand what that means and why you're doing it, and what that is, and how we can work around it, right? That what you get as a reaction from that, not just from architects, but from clients and everyone, is like, what you understand there is, well, let's work together to see what that means and how we're going to work our way through it. And is that the right thing to do? And can we do it another way? For example, if we wanted to remove this column, right, you'd probably need a steel beam spanning from that column to that column, right? That would be so low that we would bang our heads, right? So that ain't the solution. But what is the solution? What is this? I can tell you right now what the solution is. I don't even know what this building is, right? That's not the solution. But there is another solution, right? Sorry, I shouldn't say I know what the solution is. I shouldn't say that, right? I know a number of different solutions that we can explore, right? But I don't know. And the thing is, me as the structural engineer, I can't determine that solution. I need a team of people, right? I can come up with crazy structural engineering, but how do I know that this beam would be not fit the architecture? I don't know. So we need a lot of different people to contribute. And what we'd be thinking about here is putting the solution above this floor, right? Whatever that means, I don't know. But we think of a solution above that floor. Exactly what we did at Claremont College. At Claremont College, we removed, the hall was too small for the whole school. And they wanted to remove these 2 columns, and we were just doing a little work. We were just knocking a hole in a wall and putting a lintel in. And Bruce said to me, come with me, and I'll show you something. And I said, okay. And he goes, see that column? We can't fit the whole school in here because that column hinders the view. I want to get rid of it. 18 months later, the column was gone. And Bruce turned to me as we stood there in the space and said, Bruce goes, we can now fit the whole school in the hall. And he turned to me and said, Damian, we've been trying to do this for more than 12 years. And we've had 2 of the biggest architectural structural engineering firms in Australia come here and say it's impossible, right? And I said, yeah, Bruce, well, the reason they're saying that is because they don't understand the power of the ecosystem, right? Because as soon as Bruce presented that problem to me, I said, we need an architect, we need a builder, we need a structural engineer, and we need the client. And through that, 2 weeks later, we presented these options, which are trusses above and one in the roof and all sorts of things. And I could not have done that without the team, right? Because otherwise I'm just flying blind, right? And it's the team that makes that solution, right? And I also told Bruce that I never shy away from a challenge. So, yeah. But they were trying to get rid of those 2 columns, there were 2 of them actually, for over 12 years as the school grew and didn't fit in the hall. So they'd have one assembly outside and one assembly inside. So, yeah, I think you've just got to think about, you've got to work together to think through these solutions. And that's the power of collaboration.
So what would you recommend we do, like, for example, if we were working on the FIC building and first let's count the FIC building, and we wanted to put the trees in as columns, but you weren't the engineer, and the engineer we did have said no, it can't be done. What do we do then? Do we believe them, or do we?
Yeah, well, Daniel.
We're an organisation like FSC who hasn't got budget for a second engineer. Like,
yeah.
Can we just trust that it can be done and ask them to try harder? Like,
yeah, that's a tough one.
Yeah.
I don't know the answer. I love a good challenge though. I'll think about that. But what I say is that you're more likely to get a positive outcome when when I do the engineering and I see that the solution could be a 500 deep beam, right? Let's say a concrete beam can be 500 mils deep, right? If I look around the room, right, and I see someone who's going to screw with me if I get this wrong, I'll say it needs to be 600 mil. But if I look around the room and say this is a safe zone to play, right, and I'm never going to get blamed if something goes wrong, just like those trees, I will never get blamed. There'll be 10 people jumping up and saying, no, let's solve this, let's solve it. Right, there's solutions, let's solve it, right? So I look around the room, every time I make these decisions, I look around the room and saying, who's going to screw me here? You've got to set up a system. The best outcome there is not about whether the engineer, because these are trusted advisors, right? You're relying on trusted advisors, right? And that you have to trust them. And if they say no, you've got to trust that you can say no. I wouldn't be pushing them. And not a lot of engineers that I work with, if I say no, even if I have a doubt that it might or might not work, no one will push me, right, to say you've got to work harder. I don't think that's the right outcome. The right outcome is we've got to set up an ecosystem where we're going to get the best outcome, and then we've just got to we've got to live inside that ecosystem.
What do you need to do with the trees? You need to recalculate and then you need to measure the strength of the tree.
Correct. So we got, this is becoming very technical, but we got Richard Forster, who works for a company called Trees. Trees New South Wales or something, and he gave me all the parameters that I needed to do the analysis. So we did a 3D model of the timber using the properties that he gave us. So as I said, it wasn't easy, and but the trees are, I think they're bloodwood, so we were very lucky, right? Because it was the bloodwood trees, which are there was one that wasn't bloodwood, and I can't remember what it was. It might have been ironbark, but we were very lucky with the trees that they cut down there because they could be used. So he gave me all the parameters, and the weakest point is where you've got the main trunk, and where it splits, you get this cone that shoots inside the trunk, and it's from that you have to measure what the diameter of the effective area of timber that you can use. And from that's where we calculated what the capacity was. Yeah. Without trust, I'll say this, right? Without trust, we're all lost.
Back when you mentioned the Sagrada Familia, it's like one of my favourite buildings. How it's all designed upside down in tension, and then I guess if it's in perfect tension, flip it up the right way up, it's in perfect compression.
Did you go down to the
Yeah, awesome.
Yep.
And like, have you had the experience to kind of work in a similar way in your practice? Like, because it was at the time it was such a radical idea.
Yep.
I was like, is that continued on in any kind of capacity?
Absolutely. Brick is a classic one, right? Brick is, as I said, I think brick is going to be banned as a structural material, but brick is one that's, it's good to be very experimental with it. William Smart did his building in Surrey Hills or whatever it is. And it's actually, brick is not really the structure, it's actually a concrete facade, but experimenting like that is a lovely place to be. So yeah, I'm going to say we don't do a lot of that. And one of the big things about, like, Barcelona's never been hit by an earthquake, right? And that's lucky. But Barcelona now has earthquake codes, whereas it didn't when it was originally built. So I don't know if you know, but they've had to change the granite that they use for the columns to precast concrete that are post-tensioned because of earthquake. So yeah, a lot of things, I mean, we are bound, I suppose, in a way by our codes and limit state design, which is the philosophy that we use. But yeah, I like experimenting with concepts rather than details like that, if you know what I mean. Like the idea of solving the problem of removing this column, conceptually, what is that? And that's a great place to experiment. Or the waterfront tavern, where you're like, if I can just shuffle these columns around, I reckon I can get a more efficient structure. So it's conceptual, and maybe that's the engineer in me, but that engineering thinking about problem-solving architecture is not any different. But that whole idea about, let's think conceptually. What's the process that we go through to solve a problem? I love that conceptual process of like, okay, there's a challenge here, let's work through it. And I think if you can nail the process, you can always find a solution, right? Yeah. A beautiful book I'm reading at the moment called Thinking Clearly by Hazard Lee, who's an F-16 fighter pilot in the US. Talks about you should do, similar to this, you should do assessment, right? And then at a critical point you say stop, then you choose, and then you execute. And he does a lovely kind of synopsis of what that assessment looks like and what you should do, and how to do it, right? You're fighting a fighter pilot and you're making these decisions. Like, I don't think it's that stretch to say that's what we do as designers as well.
Do we have any questions? Okay, we'll leave it here. Thank you very much.
You're very welcome. Thank you. Thank you.